Adhesive tape was invented in 1925 as a painter's masking tape for auto body shops. That led to transparent tape, designed to seal the cellophane wrap used by the food industry. Then tape was introduced as a household item, and the idea just stuck. These rolls of plastic film, called polypropylene, are on their way to becoming shipping tape. The rolls go on a machine called the unwinder. Workers then position a strip of adhesive splicing tape along the end of each roll. This will enable them to connect one roll after another, creating an uninterrupted feed to the production line. Now watch closely. Once a roll unwinds completely, its end sticks onto the splicing tape at the beginning of the next roll. Once that roll's unwound, its end will stick to the beginning of the next, and so on. An automatic tension adjuster ensures that the machine pulls the film evenly to prevent ripping. The unwinder also applies a solvent to the film surface. This prevents the film from sticking while unrolling. To transform this film into tape, they coat one side with a hot adhesive known as hot melt, made from several ingredients. Synthetic rubber gives it flexibility. A UV protector keeps it from drying and discoloring, while an antioxidant prevents aging. Synthetic resin makes it sticky, while pigmentation oil provides a choice of colors, in this case, tan. They load the hot melt into a preheated holding tank, which maintains it at a piping 200 degrees Celsius to keep it from hardening. The tank pumps the adhesive to a machine called the gluer. They wipe away the excess, then roll the film. And there goes the adhesive. A cooling roller, that black one on the top, immediately hardens it. A computerized sensor ensures there's an even coat of adhesive. If not, it automatically signals the pump to adjust the output. Now, a machine called the rewinder rolls the tape onto spools. Remember the unwinder that spliced the rolls together? Well, the rewinder unsplices them. When a spool fills, a knife separates the tape at the splice point so that winding can begin on the next spool. The tape on just one of these spools would run the length of 85 football fields. The spools feed a row of sharp razor blades called the slitters, which divide the 1.5 meter wide tape into several strips. Shipping tape is 48 millimeters wide, so they get 31 strips per spool. Each strip winds onto a cardboard core, its end sealed with a tab. The length of tape per roll varies according to the customer's specifications. As the machine ejects the finished tape rolls, in comes the next batch of cardboard cores. Then it's off to the packaging department. Nothing's shipped out, however, before a quality control check. They test a sample roll from each spool. In one test, they unroll the tape sticky side up, then release a tiny stainless steel ball down an incline, measuring how far the ball rolls before it sticks and comes to a stop. To pass the test, the ball has to adhere within a certain distance. The stopping distance varies depending on the type of adhesive tape. Around 1000 AD, craftsmen began making intricate window designs using lead rather than wood or plaster between pieces of colored glass. Before long, the church was commissioning stained glass windows depicting religious scenes to adorn the great cathedrals of Europe. You can make stained glass two ways. Using copper foil, a technique developed about 100 years ago by the American artist Louis Comfort Tiffany, or you can use the centuries-old European lead technique, which we're about to see. First, the artist lays a plate of glass over a pattern and traces the parts of the design that she'll cut from that plate. Then she scores her trace line using a glass cutter. A quick snap, and the glass separates neatly. She follows the same procedure with different colors and textures of glass for all the pieces of the design. By running the cutter slightly inside the trace line, she leaves room for the strip of lead that will later hold the pieces of glass together. Once she finishes cutting all the pieces, she checks them against the pattern, making sure they fit together properly. Now it's time to assemble the pieces using the pattern as a guide. This zinc molding will frame the panel, its inner groove fitting over the edge of the glass. The artist positions this molding along the perimeter of the pattern. Then she drills an L-shaped wood frame into the work table to hold everything in place during assembly. A few nails keep the molding in place. She'll join the pieces of glass using strips of lead called came. Lead because it's soft enough to bend to the shape of the pieces. After straightening out a long strip of came, she cuts the various lengths she needs to border each piece of glass. The came is shaped in such a way that the glass on each side just slides right under. The cutting pliers, called nippers, are specially designed to slice through the came without deforming it. Once the artist finishes assembling the glass pieces, she pushes everything gently against the wood frame. This squares the panel and ensures the pieces fit together snugly. Now she brushes on flux, a type of acid. This cleans the lead came so that solder will adhere well. Using a soldering iron, she applies a bead of lead and tin solder wherever two strips of lead came join. Then she uses a short bristled brush to coat the lead in black putty. This makes the seams watertight and gives the lead a darker, aged look. Finally, she sprinkles on calcium chloride powder called whiting. This sets the putty and polishes the glass and lead to a shine. After 4 painstaking hours, the panel is finished. More elaborate stained glass works feature hand-painted detailing. The artist first prepares a design on paper, then cuts the pieces of glass accordingly. He paints the design outline on the pieces in black, then fires them in a kiln to set the paint. To create shading, he applies a coat of brown paint called grisaille. Using a dry brush, he removes it from the parts he wants to highlight, then he fires the glass again. Now he paints in the final details and fires the glass for one last time. The paint contains powdered glass, so the intense heat of the kiln bonds it to the glass pieces. The result is nothing short of spectacular.
The terms casket and coffin are often used interchangeably, but their use as synonyms is no open and shut case. Coffins are actually those 8-sided burial boxes that are narrower at the bottom. Think Dracula. Whereas caskets are rectangular. They can be made of metal, plastic, or wood. Whether the wood is ash, oak, mahogany, or something else, the casket's construction is generally the same. First, they run wood slats through a machine called a molder. This profiles the edges, carving a tongue on one side of each slat and a groove on the other. A worker applies glue to these edges, then positions the slats in a rounded vise that locks the tongues and grooves together. The glue dries in an hour and a half, bonding the slats permanently into a large curved piece. This piece will form the top and long sides of the casket's rectangular cover. To complete the rectangle, a worker now makes a V-shaped cut on each side and glues in a triangular piece of slatted wood. While a press clamps the components tightly together, he secures the end pieces in place with joint fasteners, which are like heavy-duty staples. Now a machine carves a groove into the cover's underside at the midpoint. A worker glues in a wooden piece, securing it with joint fasteners. This piece is called the bridge, and it's the point at which the cover will be cut in half later on. They transfer the casket cover to an automated machine that gives it a rough sanding, then a finer sanding. The next step is to attach a decorative molding to the base of the casket cover. This molding has a groove on the inside into which they'll later tuck the edge of the casket's upholstery fabric. A worker glues a small piece of wood in the groove at the midpoint so the groove won't show when the cover is open. Now he saws the casket cover in two, right through the bridge. Meanwhile, another worker assembles the bottom of the casket called the box. He glues together the sides and applies a bottom molding, securing everything with joint fasteners. At this point, the box is upside down. He attaches the bottom, then flips the box right side up. Now it's time to join the cover and box using 4 hinges. They spray the casket with one of countless shades of wood stain, then rub it in equally over the entire surface. The casket goes into an oven for an hour to dry the stain. Next, a worker sprays on 2 coats of lacquer with 40 minutes drying time between applications. This happens to be a high gloss finish, but many models have a duller sheen. Once the lacquer dries, a worker attaches handles. The more expensive the casket, the fancier the features. This higher-end oak model with decorative corners has wood and metal swing handles. Other models have all-metal swing handles or fixed bars made of wood, metal, or both. The fancier caskets also have an adjustable wooden bed inside with a mechanism to adjust the height. A worker covers the bed in fabric. The base model bed is made of absorbent paper laid over a product called wood wool, which is simply shredded wood. The upholsterer lines the inside of the casket with foam, covering it with either velvet, satin, or silk polyester crepe. By folding, nailing, and stapling this fabric a certain way, she creates pleats, tufting, and other design details. Generally, the more expensive the casket, the finer the fabric, and the more ornate the upholstery. A decorative trim hides the staples. Fabric straps or metal elbow brackets hold the cover open. When it comes to how beautiful and elaborate caskets can be, the ground's the limit.
Modern bathtubs look nothing like tubs of the Middle Ages or those wooden tubs we see in Western films. To achieve supreme comfort, the designer explores new shapes via computer and design software, tools which make for speedy review of various shapes. Then a model is produced. This one, produced on a 1/6 scale, is made of cardboard, but other models can be made of clay, polystyrene, or by stereolithography. Manufacturing begins with an acrylic sheet. It is heated to about 200 degrees centigrade with ceramic elements. The sheet becomes soft and malleable. So that it takes the form of the mold, thousands of tiny holes in the shell suction the sheet by vacuum. The mold must cool before it can be opened. Powerful ventilators blow air directly onto the mold, lowering the temperature to 77 degrees in 4 to 6 minutes. The ventilators are then withdrawn. Then the shell is easily removed from the mold, and that's because it weighs a mere 16 kilos. To make a tub in another shape, they change the mold. They put it in another acrylic sheet. It is heated on the ceramic and fiberglass mold. The little holes vacuum out air, and the job is done. At any rate, the molded acrylic sheet is not sturdy enough to be filled with water, so it must be reinforced with fiberglass. This is the fiberglass. Mixed with resin, it is blown onto the mold by a robotic unit. Stored in reservoirs, the resin is carried to the robot by pumps. Here it produces a chemical reaction between the fiberglass and the resin, which produces a reinforced shell. Laminating is one of the most important steps. With brush and roller, they eliminate all air bubbles which could weaken the tub. This makes the fiberglass resin adhere perfectly to the acrylic shell. The process requires 75 minutes. The shell is then transported to the milling department. The shell is now dry and hard. They can extract it manually, but here they use digitally controlled machines. The operation begins with the trimming of the edges of the bathtub. During this operation, the robot will also pierce openings for the drains, the whirlpool jets and the air jets, for the overflow as well as for ambiance light. The bathtub, almost completed, is now sent to another workshop. They can now install the pump, the piping, and the blower. These last operations are done manually. The pump is installed for the whirlpool system as well as the PVC pipes, whose joints have been hermetically sealed to prevent any leaks. Finally, to make sure that everything is functioning well, each bathtub undergoes a water test. Some 13 steps have elapsed, plus 3 to 5 hours of work depending on the tub being made. It almost invites you to climb in.